Okay, so today we're just going to have a quick look at a few different motors that are available in the world of hydraulics. So we're going to just start with this one here at the moment. This is what we call a gear motor. This particular one is commonly used around air seeds. One of the reasons or ways we can quickly identify this as being a motor as opposed to a pump is that on both sides you'll notice that the ports are the same size, and you'll also notice in the back cover here we have a thing called a case drain, which is also commonly used with hydraulic motors. Today we happen to have a brand new fit up happening at the moment with a new centrifugal water pump being fitted to this water truck. A couple of things I'd just like to point out. This is obviously a hydraulic motor in this case here, and on this particular application is that we're turning a hydraulic motor which is turning a hydraulic water pump. So what happens is that this particular unit is designed to spin at 2,900 RPM. That means that this shaft in here is spinning at 2,900 RPM to turn that. When we suddenly stop the oil flow happening to this motor, we don't want this pump to suddenly want to keep turning while switching the oil off. This forms like a very fast braking action. And when you have a very fast braking action, it'll have a dog bone of sorts inside it, similar to what I've got in my hand. If that's not allowed to slow down at the correct speed, we'll actually break this part inside this hydraulic motor. So it's one of the things that you need to be fully aware of when you're setting up these applications, is to make sure the circuit has got some form of a run-on check assembly which allows this motor that's fitted to this pump to slow down at a speed that it is capable of slowing down at without breaking anything. The next motor we might look at here, just to show you some different motors. This here is what we call a bent axis piston motor. It's actually what we also refer to as being a fixed displacement motor. This particular motor in my hand here is about 11 or 12 cc's, probably 11.8 if I wanted to be exact. Yet again, same sort of principle, same size ports on either side, and case drain off the top. Case drains are put onto hydraulic motors purely so that you can take the pressure away from the shaft seal when it's actually in operation, and becomes a must or a certainty if you start hooking motors up in series, in other words, one after the other. As we turn around here a bit more, we'll pick up this big baby here. This here is what we call a wheel motor. So in other words, it's the sort of motor you'd find on the front of a Bobcat or something similar to that. It's what we call a Girola motor. So a Girola motor will look like this one here. It'll have a thing in it usually called what we refer to as being a dog bone. We have a series of rollers which run inside this housing, so we call that a Girola motor. So this one here that's in pieces at the moment, just to confuse you, we call that a Girota motor. So this is a Girota, like a star, and that is continually rolling around inside that housing there. Obviously, oil coming in, oil going out, which is doing the driving of the shaft. Charlene motor apart here at the moment. Before it was disassembled, you would have noticed that first thing we would have picked up on is it's all got broken pieces out of the front cover here, which obviously means that something drastic is going on inside. We also have what we call the housing, which is what our drive shaft acts as a valve through the centre here. This slips inside this housing. Some of the things that have written this motor off is purely if they're put into an application where someone hasn't run a outrigger bearing assembly on them. What generally happens is they put side load on the shaft, causes wear, as we see here, happening inside the motor. One of the reasons this motor will never go together is that this surface area where my fingers are there now, that's where the main shaft seal goes. That's what keeps the oil in the motor, and obviously it would have been pouring oil everywhere. This particular one, it's in really bad condition. We've just looked at this one that's been pulled apart here. What will happen to that one we just looked at? The customer will be handing one of these back in its place and saying that the old one was beyond repair. One of the things that often happens inside a hydraulic motor when it has a complete failure, it stops completely, is usually, even though that looks like a big solid piece of steel there, It's not unusual to pull these apart and find that that dog bone is actually broken in halves. And normally puts metal through everything when that happens. A lot of these sort of motors are dictated to different speeds they can run at and different system pressures they can work at. The benefit of this one here in the centre here being a bent axis piston is that it's capable of extremely high speeds. This particular hydraulic motor here is good for 5,000 RPM, which is mainly used around air seeders and stuff where you want the extra fan speed to create the extra blast for air seeding. This one here also is used on different types of air seeders, and your speeds can turn up to around your 3,000 RPM range without too much drama. One of the big things about these particular motors, especially in the Gerada and the Girola style motors, the biggest mistake most people will make with this particular motor here is the system pressure on their machine is set too high usually. You'll do damage to this motor very quickly. For that, questions you need to ask at the front counter when you come into the shop to find out whether your tractor needs to have some form of a relief valve put in play to enable it to protect the motor when you want to use it, put it into use. So just little things you need to know. But yet again, if you come here to BG Hydraulics, we'll be able to limit your downtime and limit your amount of money you spend on things due to the fact that you can expect them to work instead of getting broken. Okay.